6, lesson 5. Might be part 1. We'll see if we break it into 2 parts or not. But all right, so in this lesson, we're going to determine the exact values of the 6 trig ratios for these specific locations in the unit circle: 0, 30, 45, 60, and 90. So that means that every quadrant has 3 cuts. Okay, has a 30-degree cut, 45-degree cut, and a 60-degree cut, along with the 0 and the 90. Okay, so those are the key locations for the unit circle. So the unit circle, okay, I'm just going to get ahead of myself here. The unit circle is specific to 30, 45, 60. And so that means you have those cuts in every quadrant. Okay? So essentially, the unit circle, if you count the axes, has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 locations. The unit circle has 16 locations. Okay? All right. And knowing these in radian and degrees is what the expectation is for the unit circle. All right, so let's go through these. So the diagram shows an angle of 45 degrees or pi over 4 in radians in standard position. The terminal arm has a length of 1. So what this is also, unit circle is going to have a radius of 1 all the way around. Unit circle is going to have a 1 radius all the way around. Okay, so they keep it simple for you in terms of that value. Okay, so what I want you to do here is determine the length of the isosceles triangle, give your answer in exact form. So what they're trying to do is they want us to figure out the lengths of x and y here. Okay, this is your y value, that's your x value. How could you do this? What do you know about 45-degree triangles? Right, so if this is 45, that's 90, and this is 45. So what do you know about their sides? They're equal, right? 45, 45 has equal legs because they have equal angles. So then what you're going to do is, if we're solving for this, if we just called this S and S, we could still use Pythagorean Theorem. We would say 1 squared equals S squared plus S squared. This is the idea of special triangles. Okay, you're not going to do this every time. This is help developing where the values for unit circle come from. Okay, so if you're like overwhelmed already, just pause. We're kind of building up some values. Okay, so what's S squared plus S squared? Well, that's 2S squared. Who remembers from last lesson? Okay, we did 45 degrees. Remember? What was that? What were those 45-degree stuff look like? Do you remember? They all had root 2's in them. Remember that? On the previous lesson, when you did root 1 over root 2, we got 45. So watch this. Here's where that 2 comes from. 2. What's 1 squared? Just 1. So I have 1/2 equals S squared. Is everybody with me? Divide the 2 over. And then what do we do last? Square root. So it's square root of 1/2. Well, how do you square root a fraction? You square root top and bottom. But square root of 1 is just what? 1. So it's 1 over root 2. And it's plus or minus. But remember, we saw that. We had 1 over root 2. We've done that already. That's where the 45 degrees came from. So 1 over root 2 is the value at 45. But they're going to go a step further, because what's wrong with this when you look at it? Remember your math 20? What do we do with root 2 on the bottom? What do you do with root 2 on the bottom? Yeah, move it up. We rationalize, right? So this, root 2 over 2, is the one you're going to see a lot today. Root 2 over 2 is 45 degrees. Is that still plus or minus? Yes. In terms of this question, they're both going to be positive because I'm positive x and positive y. So it's actually positive for this where I'm solving. But yes, all those values can be plus or minus. Okay, so with the root 2 over 2, guys, check this out. So then what do we think? We just did sine of 45. Remember, sine is the y. So what was that y piece? Well, just what was s? Root 2 over 2. What was the cosine piece? Same thing, right? They're equal sides because they're 45, 45. So they're equal spots. Okay? These are the same thing, right? Sine of 45 and sine of pi over 4 is the same spot. So these are all the same. Let's see if you can figure this out. Tan of 45 then is what? 1, because it's same over same. So sine was this spot here. So we just did 45, and we solved for these sides. We got root 2 over 2 and root 2 over 2. This is the sine piece. So root 2 over 2 is sine. This is the cosine piece. These are the same. Tangent is y over x. So root 2 over 2 over root 2 over 2 is same over same for 1 and 1. That's where all those values came from. That's the 45 piece. Okay. Now, let's look at the pi over 3 spot. Theorem 2 shows the angle of 60, or pi over 3 in standard position. The terminal r has a length of 1 unit. So this diagonal here, again, is 1, like always, the radius. Okay. An equilateral triangle is drawn whose equal sides are all 1. So it's just showing you this whole thing's 1, this whole thing's 1. This is just for understanding. Okay, and the two congruent triangles. Determine the length and the altitude. So we're going to try to figure out the length and the altitude here. So if this is an equilateral triangle, what happens when it comes down here to the bottom? What do you think happens to those values? Well, it's going to come down, it's going to bisect them. This is how you know that. See how this is 60 and that's 90? What's this sliver have to be? 30. So these are both 30, right? So 30 and 30, they're going to make equivalent lengths. Well, this whole thing's 1, this is 1/2, and this is 1/2. Does that make sense? And we need to figure out what A is, the altitude. We'll have to do a little Pythagorean theorem for that. Okay, the whole, it just tells you it's an equilateral triangle, right? Yeah. So that means it's 1 all the way around. 1, 1, 1. I just explained that this right here, since those are 30s, these are equal. So half of 1 is half. The whole thing's 1. Does that make sense? Can you do it with 60 and just keep it 1? Well, okay, good question. But we're actually looking at this. This is what we're actually looking at. So we want them in a 30-60 triangle. But we'll get to what you said here in a second. Okay, so now we just got to figure out A is real quick. So we have to do Pythagorean theorem. So we're going to go 1/2 squared plus A squared equals 1 squared. So leg squared plus leg squared equals hypotenuse squared. So 1/2 squared, remember squaring fractions, square top and bottom. I get 1/4 plus A squared equals 1 minus the 1/4. A squared equals 3/4. And we square root. I can square root the 4, but not the 4, but not the 3. So it's root 3 over 2. Root 3 over 2 is one of your main values for the unit circle. Okay. So see that part that I've outlined in green? If I asked you, let's say this is the origin right here, which it is. If I asked you what is this point right here, what would you tell me? What's the point right there? Right. X value, Y value, right? So X value is 1/2, Y value is root 3 over 2. That's a location on your unit circle. 1/2 root 3 over 2. Okay. The X value and the Y value. Okay, so we got A, so now we can do what sine of 60 is. What is sine of 60? So sine, I tell you, goes with the Y. So what value do we want? Root 3 over 2. Okay. Pi over 3 is the same thing. Pi over 3 is 60. What's cosine of 60? X value. 1/2. And then tan, we want Y over X. So tan, we're going to do a little bit of work, but it kind of actually simplifies kind of nicely because look, it's root 3 over 2 over 1/2. Y over X, right? Y over X. We'll see what happens with the 2's. They're going to cancel because you're going to have an underachiever and overachiever. The 2 goes here, it's going to cancel. Root 3 over 1 is what you're going to have, so it's just root 3. you don't like it written vertically, you could write it like this if you're better with. So if you're doing division, it's multiply and flip, right? You can see it there too. Okay? So we're developing. You guys now, we have now identified all values you need to know for the unit circle. It's just about when and where. Okay, so I'm going to write this out real quick for you. You might put this in your notes. These are all the values of the unit circle. We'll go from smallest to biggest. Okay, 0, 1/2, root 2 over 2, root 3 over 2, 1. All of them will be positive, negative in different spots, but those are all the values of the unit circle. 0, 1/2, root 2 over 2, root 3 over 2, and 1. Any questions so far? Okay. So they're going to have us do the 30 triangle, which is going to be silly. You're going to see why. So if we look at this 31, the pi over 6, well, we already know what a 30 degree made. Remember? So this is an equilateral triangle again. So this is 60, this is 30, this is 1/2, this is 1/2, right? So we already know what that's going to be. Essentially what happened there, the x and the y flipped, just because our angles flipped. So we went from a 60 to a 30. Okay? Here's another way I want you to think about this, and people don't understand this, but I think it's important for understanding the unit circle. 30 is going to be a smaller height. Right? This 30-degree angle, is that smaller than 60? Right, and so it's going to make a smaller height here. 60 makes a bigger height, and so 60 is going to make the bigger number of root 3 over 2. So 30 makes the 1/2, 60 makes the root 3 over 2. Okay, so comparing the two. All right, because those 30, 60 is the only ones you can get mixed up. Okay, think about it in terms of heights. But the point is, what is sine of 30 here? So don't look at what I have written there. That was for 60. So let's get rid of this here. So 30 is, for y, 1/2. Remember, sine, think y. Cosine, think x. If you're still confused why I'm pulling which one's for sine, which one for cosine. Pi over 6 is the same thing as 30, 1/2. Cosine of 30, now that's my length here, root 3 over 2. Pi over 6 is the same thing. Tan, so if I do y over x, so let's go ahead and do that, be 1/2 divided by, let's go multiply, because we're going to flip and multiply. Multiply 2 over root 3. So see the 2's still cancel, but I have 1 over root 3. Let's go ahead and rationalize that. Makes sense, right? The last one we got root 3 over 1, this one we got 1 over root 3. Well, they're flipped in degrees. It makes sense. So this is going to be root 3 over 3. Root 3 over 3. Okay. That's tangent. So that represents tangent. It doesn't represent hypotenuse, no. Tangent is a comparison of the y and the x ratio. Okay. Hypotenuse is just 1. See, that's all you know about the hypotenuse. Okay. Good question. Okay. Anything else? Okay. Let's finish these special triangles, and we'll get to the labeling of the unit circle. Okay. So here's what we just defined, guys. We defined these special triangles. This is what's important. These are patterns. Special triangles hold these patterns all the time. These numbers can change. Like, what if I told you your radius was 6? What would your 30-degree side be? Yeah, 6 by 1/2, right? So this would be 3. Okay, so I want to show you the pattern piece for a second. So what I said was, if I told you that was 6, let's say our circle is 6, and they're all going to be 1, that means that the 30 side's half of that. It's 3. Now here's the interesting part. Okay, root 3 over 2, right? So what that's going to be is it's going to be, see how this is, I'm going to write this 1/2 root 3. Root 3 over 2 is the same thing as 1/2 root 3, right? Well, what is half of 6? So it's 3 root 2, 3 root 3. It's like you're still timing the 6 to it. So you get 3 root 3. Okay? But anyways, it holds a pattern. So that's how it's going to be whenever your radius changes. We're going to be dealing mostly with 1, but I don't want you to be boxed into that. If they just simply change your radius, you just times your stuff by that. Okay, if it's 4, you go 4 times a half, 4 times root 3 over 2, 4 times 1. Okay? This one, same pattern. Same length, same length. Same length, same length. Okay? So, let's complete these now. Let's get, what's this got here? All right, so, sine of pi over 6 or sine of 30 we know is 1/2 from what we did. Cosine's root 3 over 2. Tangent is the root 3 over 3. That's the one we just did. Just above. Pi over 4 is the easy one. Sine is root 2 over 2. Cosine's root 2 over 2. Tangent's 1. And then pi over 3 you're going to see is the flip of 30, or pi over 6. It's going to be root 3 over 2, 1/2, and then it's going to be root 3. All right, now we're almost there. So let's get the unit circle done, and then we'll stop halfway through this one. Let's call this part 1. Okay. All right. So if in each triangle the horizontal distance is x and the vertical distance is y, hypotenuse is 1. Express the following trig ratios in terms of x and y. So what they're just saying is we know the sine ratio is y over 1, which is just y. That's what they're saying. That's why I keep telling you to say sine is y. The sine ratio is y over 1 because that's the hypotenuse. Cosine ratio is x over 1, and tangent ratio is y over x. That's why we're calling the sine y. That's why we're calling cosine x. All right, so here is the unit circle in a nutshell here. Creating the unit circle. Okay, so all of these spots are going to be symmetric over the x and the y-axis. So what that means is this one will mirror, like this 30 will mirror over here, 30, because of reference angle, right? 30 from the 180. Also will mirror down here, 30 from the 0 spot. Okay, so they all reflect. Another way of remembering it. Okay, but here's the thing. 0 degrees is going to be 1, 0. How did I get that? 1 for x. Y didn't go anywhere. There is no y value, so y is 0. Up at the top, your 90 is going to be 0, 1. 0 for x, 1 for y. Now, this is what we're talking about in terms of heights, is the best way to remember this. When you look at the 30-degree cut, that's this cut right here, what is bigger, the x or the y? The x is. So the x is going to be your big value. What's the big value? Root 3 over 2. What's the small value? 1/2. So this point is root 3 over 2, 1/2. Let's jump to the 60 since they're similar. So the 60, they already have it here for us. Here's the 61. What's taller, the x or the y? The y is. So the x is the 1/2. The y is the root 3 over 2. That length there. And the easy ones of 45 because they're the same thing. Root 2 over 2, root 2 over 2. And those are between these values. Okay. Any questions on that? Yeah, and then it's just mirrored positive negatives. So like just if I'm over here, if I'm in quadrant 2, my cosine's now negative, so all my x values are negative, but my y's are positive, but it's the same stuff. Okay. All right. Okay, so we did that for A. How do the coordinates of the points relate to the measure of the rotation angles? Okay, so the x coordinates are cosine. The y coordinates are sine. Complete the chart. Okay, so we're going to complete the chart here. So the chart we have sine theta. We have this one, we know it was 0 at 0 because the y is not going anywhere. Cosine's 1. Tangent 0 because we can do 0 over 1. pi over 6. Your sine ratio for pi over 6 was 1/2. Your cosine was root 3 over 2. And then your tangent was the root 3 over 3. We already wrote these out, so just kind of being repetitive a bit. Pi over 4 is the same. Pi over 3 is the flip of pi over 6. And pi over 2 is 1 for y, 0, undefined. Can't divide by 0. So there's no tangent ratio at 90 degrees. Okay, so complete the following. The sine ratios increase from 0 to 1. The cosine ratios decrease from 1 to 0. Okay, so looking at sines increasing, cosines decreasing. That makes sense because look, when you're coming around this corner here, as I'm going this direction, my y values are what? Getting taller. Right? As I'm going around the circle this way, my y's are getting taller, so that's why your sines are growing. But I'm also going this direction. I'm also actually technically, I'm turning. Which way am I turning? Left. So I'm turning left. That's making my x values get smaller. So I'm turning left. Okay? Good. Tangent ratios are equal to the sine divided by the cosine. Explain why pi over 2 is undefined for tan. 1 divided by 0, can't do it. The 0. Okay, we'll fill out the unit circle and then we'll stop, guys. We'll fill the unit circle and we'll stop. We'll do examples tomorrow. We're gonna fill out the right here. Yeah, so we're gonna talk through it though. I know you're done, but I'm sorry. Okay, so what I wanted you guys to look at was, because I want to finish what Cash was saying, this is important. Root 3 over 2, 1/2, it's symmetrical here. See, it's the same exact coordinate, but the only thing that changes is the sign. The x value changes. It's also, both these points are also symmetric there and there. So see this little box, this spot, this spot, this spot, and this spot are all the exact same coordinates. The signs just change. That's why it's not hard to get the pattern down. Okay, for memorization, but also understand where the pattern comes from. Okay, these ones are the easy ones because every spot of 45, they're going to be same, just sign change. The only thing you got to work on is root 3 over 2. Which one is it, the x or the y? I mean, whatever you want to remember that. I always think about lengths. So for example, here, y is a smaller piece, so that's the 1/2. Right here, x is a smaller piece, that's the 1/2. Okay, which is the smaller versus the bigger? Okay. Okay. And to finish this page, in the unit circle, radius is 1. We have sine theta is y, cosine x. We've already said that a million times. And then every point in the unit circle has a tangent, sine over cos, or cos over sine. So, for example, if you want cotangent, is cotangent pi over 2 a possibility? Remember, tangent wasn't, but cotangent, is it? Yeah, it is, because now if I go pi over 2, it's going to be 0 over 1, which is okay, because I flipped them. I'm just talking about that pi over 2. Tan of pi over 2 we couldn't do. We couldn't do it. But cotangent we can. It'd be 0 over 1, so it'd be 0. All right, we'll stop there.